Moving along to our next speaker, Jakob Carnemark, the CEO of Endeavour. Jake is the founder and CEO of Endeavour, a sustainable infrastructure company that is partnering with cloud companies, utilities, logistics, and critical facility operators to build a gigawatt-scale network of zero-carbon data centers, microgrids, and EV charging facilities. Jake is a seasoned entrepreneur with a long history of creating sustainable solutions for mission-critical projects. He founded Skanska Mission Critical in 2001 and later founded Aligned Energy, which grew rapidly into a multi-billion-dollar company. In 2019, Jake founded Endeavour to develop and scale a new generation of decentralized technologies with the potential to make clean energy and water accessible to communities worldwide. Endeavour is currently creating a nationwide network of carbon-neutral EV charging stations for logistics and heavy vehicles that leverages grid block energy router technology and renewable microgrids. The Endeavour team is backed by the largest supply chain ever assembled to deliver edge infrastructure on demand. So after hearing a little bit from Dr. Divan on the challenges, it sounds like Jake is going to give us a little bit of insight into some of those solutions. So Jake, I will now turn it over to you.
Thank you, Chris. Appreciate it. Looking forward to talking about how we approached kind of the technology solution. We're excited to work with the Center for Distributed Energy on that. So grid block that we're installing, as you mentioned, we are working on a very large logistics platform. We, again, work in the microgrid data center space and logistics. And the core function that Endeavour is taking on is we feel there are critical solutions that are not yet been developed in the market that are needed to solve some of these problems that Deepak talked about. And one of the key things that I want to punctuate first is just the mention around that, core solutions for EV charging. There's no real ROI even at pretty significant adoption of EV charging infrastructure. And this is important to companies, but it's also that are in that space, but it's also important to large fleets, logistics companies that want to deliver electrification of their fleet at a better ROI. What Endeavour is doing, it's rapidly scaling these solutions in multiple areas. And in the grid block space, one of the things that we looked at is that when we're delivering microgrids for utilities, when we're delivering data centers, unless you are constantly aware of what the grid needs to do in the sense of managing demand and supply on the grid, you're going to end up with a bigger problem. One of the most significant areas that are struggling this now are the airports that are rapidly adopting, which is a great thing, electrification initiatives. Surrounding communities around airports are adopting electrification issues, and airports are critical services to communities. They need constant balancing and good power quality. And that's an area that we focused on with grid block and are scaling up in partnership with CDE. Some of the key points around grid block and its solution and what we're trying to address is, number one, charging infrastructure has to be software defined. And the reason why you have to be software defined, and what we mean by software defined, is you have to be able to change the output by vehicle. Two things are key there. You want infrastructure that can charge multiple vehicles, a Tesla, a truck, a fleet. You also want that infrastructure to be able to adapt, to be a 20-year infrastructure. We're just starting in the charging scale. Nobody has any idea of what electric trucks, vehicles are going to be doing 20 years from now. And if you don't have a software-defined infrastructure that can adapt to that, you won't get the utilization and the return on your investment. So the grid block is at its foundation software-defined infrastructure. One of the other core features of the grid block is its multi-ported nature. In each individual grid block, you have 6 trays at 80 kilowatts apiece. They are paralleled and they can manage up to 16 ports, as well as injection directly of solar. On any of those ports, you can be bidirectional, again, to the software-defined nature of it. You can output DC or AC. So on the same charging infrastructure, you can do level 1, 2, and 3. And it can software, switch instantaneously between level 1, 2, and 3, go up to 500 kW per channel, and you can go up to megawatts if you run grid blocks in parallel. What allows the infrastructure to do that is some of the foundational kind of IP that was created in the development of grid block was essentially packet slicing of power. So the grid block works in a way where it takes those multiple channels and it's switching at 18 kilohertz. And thus, when you take in an AC line or DC, you're slicing that up and then recombining those packets on the end, just like an internet router takes multiple internet traffic and combines it. You're doing the same thing with power flows. Some key features that drives and enables is a grid block can be connected to a grid under stress, and it can, at the same time, mix and match energy sources. So batteries connected to it, solar connected to it, critical facilities. It performs the same function as a UPS from a backup standpoint, as well as being able to integrate generators, as well as some new technologies that are lower inertial mass, things like fuel cells. So that is kind of the core functionality. The reason why we focused on this solution and scaling it up for our development platform that we're doing in Edge is that we want to be able to deliver fleet charging at scale at an ROI and a cost that gives us the ability to deliver that at the adoption curve. So you're going to have companies out there that are 1-2 truck pilots. They will scale up to higher utilization over time, but you want to be able to deliver infrastructure that's going to adapt to those changing conditions over time, as well as that is going to be able to deliver resiliency to the facility. To kind of punctuate the point in a specific example, an airport can use technologies like this and start at their EV, charging lot for rentals, and then can expand to, APUs on electric planes, and then can expand to, some of their sustainability initiatives. And it literally, is something that you can build from one grid block up to several hundred megawatts of infrastructure. And the more that you put in, the more that you're able to increase the resiliency of your facility and or infrastructure. To give you an example on the left, that is the way microgrids are typically constructed. A lot of companies talk about, let's put in charging infrastructure, let's have solar, let's have batteries connected to it. All of that infrastructure on the left is contained in one grid block. So again, it gives you, plug and play infrastructure and eliminates a lot of that complexity. When you look at what that gear looks like in terms, most folks would be familiar of what, a typical charging station would look like. You'd have your medium voltage transformer, you'd have your distribution gear, you'd have your DC charging sections. If you want to include solar and storage, you need separate inverters. And again, you're taking about 36 feet of gear and bringing it down to about a 6-foot square footprint in one grid block replaces all of the infrastructure to the left. And it's not just about saving money, even though that's a key driver. It's about enabling a more simplified platform that is plug and play, that can grow over time, and that future-proofs the infrastructure. When we look at one of the other key features, and this is just about the economics of charging, the way most charging infrastructure is built today, it's built when you get into the DC fast charging infrastructure, it's built with the inverter coupled to the stall or the charging infrastructure, the dispenser, if you will, which is a solid approach, other than it creates low utilization. Unless you have very, very high traffic into that parking space, you end up with relatively low utilization on that expensive inverter. So we approach this purely from the economics of the business model and how could we achieve good returns for companies and investment going into the charging space, electrification from governments and companies, And the solution really drives that you have the ability to drive higher utilization across the inverter. So a grid block is a centralized infrastructure that's plug and play that can support up to 16 slots at once. And therefore it can roll if you're parking rental cars or fleet trucks, it can roll through them. The software does that, or it allows for, matching up of different charging profiles. As everybody knows on the call, it's interested in charging. It's not a steady state power draw. You get very high charging currents in the beginning of the cycle, and then as the batteries start to fill, they taper off. So this gives you the ability to match those charging profiles across that, and then add to the infrastructure as you build. Areas where we're starting to deploy this in Europe, we started there with a 400 megawatt platform. And again, as you mentioned, we're going to very large scale distribution across North America. A typical problem use case that logistics companies have is significant amount of cross-dock facilities. They might have a pilot starting shortly. They want to expand that over time. This is, again, critical to be able to kind of plug and play as you go and add to that. A typical installation would start with one, and as utilization grows, you can start to expand, as you need it to kind of keep pace with the utilization. So that is some of the core technology that we are driving for behind making charging models more efficient. And thank you for the opportunity to talk about it. And I'll turn it back to you, Chris.
Excellent. Thank you so much, Jake. Really appreciate that overview.